Hi, welcome back to the second part of chapter 3 on linear combinations of random variables. So, yesterday's video basically I derived the discrete random variable version and the continuous random variable version of these equations. So, if let's say you are given ex and okay, let's say ex is equals to mu x, variance of x is given by sigma x square. Of course, I also need to define ey, so I will just use a subscript y, and then the variance of y will be given by the sigma square y. So if you are given this type of statistical measures, so essentially the formula that you need to remember is as follows. So if you are given, let's say, um, q, for example, is equals to ax plus b, so a and b are constant, then your ex will be, sorry, eq will be ax plus b, and this will be a times ex plus b. So the variance of q will be equals to the variance of ax plus b, and you just square the a and then define the variance of x. So on top this will be a mu x plus b, and the second version will be a square sigma square x. Whereas if you are given, let's say, q equals to ax plus by, so the condition for this is basically x and y must be independent. Then eq will be given by e ax plus by. So this is the same as aex plus b ey. So this will be a mu x plus b mu y. So the variance of q would be variance of ax plus by. So this will be a square, the variance of x, plus b square, the variance of y. Or you can write a square sigma x square plus b square sigma y square. So these four equations, let's say this is equation 1, this is equation 2, this will be equation 3, this will be equation 4. So these four equations, basically they are the same regardless whether or not this is a discrete or continuous random variable. But for the second case, you just have to make sure that they are independent. So before we go to the exercises, I mean, technically speaking, if you can't memorize or understand what I did in the last video, because I understand that the derivation is kind of lengthy, then you can just memorize the final results. So I'm just showing you how to arrive to that results. So before we go to the exercise, there are two conclusions that you need to make. The first one is that if x and y, sorry, technically it's the same. If x and y are normal distributed, then ax plus b and ax plus by are also normally distributed. Okay. Second thing is that if, let's say, x and y are distributed by Poisson distribution, of course they have to be independent as well and are independent. Then x plus y will be distributed by Poisson distribution. The reason that you need to point out the second fact is that because for Poisson distribution, let's say x is distributed by Poisson distribution with the parameter lambda, we take note that e of x is lambda, and so does the variance of x. So the only way you can get, so the only way for you to combine, let's say, okay, let's say this is lambda x. So then this is lambda x, and this will be the variance of x. So let's say P is also distributed by Poisson distribution with lambda y. So EY will be equals to lambda y, which will be also equals to the variance of y. So the only way for you to combine these two independent Poisson distributed x and y together is by x plus y. So this will be lambda x plus lambda y. The reason why is because if you have x plus y, so ex plus y basically gives you ex plus ey. And variance of x plus y will also give you the variance of x plus the variance of y. And basically they are the same. This is not true if you have other types of distribution, for example, ax plus by. If you do that, you will find that your expected value and your variance are not the same, which is why you need to be very specific when you talk about Poisson distribution. Only x plus y will be distributed by Poisson distribution. So fact number 2 is important. So now let's look at some exercises that I found from the textbook. First one, the random variable x has probability distribution shown in the following table. Find e 2x plus 5 and the variance of 2x plus 5. So what you need to do first is to find ex. So ex will be given by 6 times 0.8 plus 28 times 0.2. So if you calculate this, this will give you 10.4. If you calculate the variance of x, this will be 6 squared times 0.8 plus 28 squared times 0.2. remember to minus 10.4 square. When you calculate this will give you 77.44. So now that you have these two values, you can proceed to calculate A by using the formula. So E2x plus 5 will be 2EX plus 5. So you just take 2 times 10.4 plus 5. This will give you 25.8. So part B, the variance of 2x plus 5, we know that this is 2 square the variance of x. So this will be 4 times 77.44. That will give you 309.76. So that's how you find those expected value and variance. Second question. The random variable x has mean, mu, and variance sigma square. Find two pairs of values for the constant a and b such that EAX minus b equals to 0, variance of AX minus b equals to 1. So you know that, so you don't know what kind of distribution this is, but you know that EX is given by mu. The variance of x is given by sigma squared. So you just apply the formula accordingly. So EAX minus b equals to 0. So EAX minus b is AEX minus b equals to 0. So this means that A mu minus b equals to 0, or b equals to A mu. So let's say this is the first equation. So the second equation that you can form is from the variance. Variance of AX minus b equals to 1. So this will be a square, the variance of x equals to 1. So a square sigma square equals to 1. This means that a would be plus or minus 1 over sigma. So now you substitute equation 2 into equation 1. So what you have is basically b equals to plus or minus mu over sigma. Therefore, when a equals to 1 over sigma, b is equals to mu over sigma. When a equals to minus 1 over sigma, b is also equals to minus mu over sigma. So these are the two sets of solutions. The third question, independent variables a, b, and c have mean 497, variance 1, 2, 1.3 respectively. Find all the followings. So the equation that we studied, so let's say x plus y, let's do ax plus by. So for example, if you find the expected value of ax plus by, we know that we can separate this. So this also means that basically speaking, you can expand. And the rules follows. So of course, similarly for the variance part, you just expand accordingly. So let's look at part A. So EA plus B plus C will be EA plus EB plus EC. So EA equals to 4, the other one is 9, and then the third one is 7. So this should be sum up to 20. So if you were to find the variance of A plus B plus C, this would be variance of A plus variance of B plus variance of C. So that would be 1 plus 2 plus 1.3, and it gives you 4.3. So the third one, you have E 3A plus B minus 2C. So this will be 3EA plus EB minus 2EC. So 3 times EA is 4 plus EB is 9 minus 2 times EC, which is 7. So what you have is 7. So part D, you want to find the variance of 3A plus B minus 2C. So this will be 3 squared the variance of A plus the variance of B plus minus 2 square the variance of C. So this will be 9 times 1 plus 2 plus 4 times 1.3, which gives us 16.2. Question 4. Given that you have this particular random variable x, find Ex and variance of x. So Ex will be 2 times 0.6 plus 3 times 0.1 plus 5 times 0.3. Calculate it, you get 3. The variance of x will be equals to 2 squared times 0.6, 3 squared times 0.1, 5 squared times 0.3. Remember to minus the mean square, which is 3 squared. So once you calculate everything out, you should get 1.8. So now find the expected value of the following. So E2x will be given by 2 times Ex, which is 2 times 3, or it is 6. The variance of 2x will be given by 2 squared times the variance of x. So this is 4 times 1.8. So this is 7.2. So part C, find Ex1 plus x2, whereby x1 and x2 are basically two different variables that has the probability distribution given by the table. So this will be given by Ex1 plus Ex2. So Ex1 is 3, Ex2 is also 3, so this is 6. So now the last one, find the variance of x1 plus x2. This will be given by the variance of x1 plus the variance of x2. So it is 1.8 plus 1.8, which is 3.6. So from this particular exercise, you can see that E2x is equals to Ex1 plus x2, provided that these two measurements follow exactly the same probability distribution and they are independent. But the variance of 2x is not the same as the variance of x1 plus x2. Okay, so this you have to take note. Question 5. The masses in kilogram of small bags of flour and a large bag of flour are denoted by X and Y respectively. You have the normal distribution. Find the probability that the mass of a randomly chosen large bag is less than 2 times the mass of a randomly chosen small bag. So over here, large bag is Y. You want to find the probability that the mass of a large bag is less than 2 times the small bag. So this is what you want to find. So what you want to find is something like this. Of course, you can write y minus 2x smaller than 0. So this is where you begin. So from the right hand side, you have seen that this thing is basically a linear combination of two random variables. So I can define, for example, let q to be y minus 2x. Then you find the expected value of q. It will be ey minus 2ex. So that will be 1.1 minus 2 times 0.51. That will give you 0.08. The variance of q would be equals to the variance of y plus 4 times the variance of x. So this will be 0.25 square plus 4 times 0.1 square. So that will give you 0.1025. Therefore, Q is a normal distribution with the mean 0.08. The variance will be 0.1025. So now what you want to find is basically PQ smaller than 0. So you need to convert to Z score. So this is PZ smaller than 0 minus 0.08 divided by the standard deviation. So you need to take the square root. So this will be PZ smaller than minus 0.2499. Or we should just round up to 25. So then you draw your bell curve. So this is minus 0.25 and this is the area that you need to find. Okay, so this will be 1 minus pz smaller than 0.25. Find out what is the value for 0.25. This will be 0.5987. So the final is 0.4013. So that's the answer. So now let's look at question 6. The distribution of the mass in grams of honey H is given by that. For jar J will be given by the other normal distribution. Find the expected total mass of 12 of these jars and the standard deviation assuming the mass are independent. So what do they mean? They mean that you need to have, for example, Q equals to 12 jars of H, 12 jars of J. Okay, so E of 12H plus 12J, we know that this is 12 times EH plus 12 times EJ. So this will be 12 times 465 plus 12 times 120. So this will give us 7020. The variance of this will be the square of 12, which is 144. The variance of H plus 144 times the variance of J. So this will be 144 times 25 plus 144 times 16. And this is 5904. But look at the question. The question asks you to find the standard deviation, not the variance. So finally, you need to find the standard deviation, 12h plus 12j. This is the square root of 5904, which is around 76.84. Okay. Question 7, you have the number of cars passing a fixed point can be modeled by Poisson distribution. So let's say car can be modeled by Poisson distribution. This is 2 per hour. Lorries you model by Poisson distribution as well. This is 3 per hour. Assuming they are independent. So find the probability that in a random chosen hour, a total of exactly 4 pass the route. So this means that you need to find C plus L equals to 4. Okay. So let's rename this. Let's rename this as Q equals to C plus L. And Q is distributed by Poisson distribution. So basically it is just 5. Because we know that EQ will be equals to EC plus EL. And this will be just the sum, which is 5. Okay. So what you need to find is Q equals to 4. So you just plug in the equation. So this will be E power minus 5, 5 power 4, and finally you have 4 factorial. Okay. So if you calculate this, this is 1755. Let's look at the last question for this video. Question 8. You have the number of letters and parcels received per weekday, and they are independent. On average, the business receives 3 letters and 1 parcel per weekday. State an assumption that is needed to model the number of items. So for Poisson distribution, previously we mentioned that it has to be, so the events happen has to be random and independent and so on. So the independents are already assumed in the question. So the other assumption would be that your items received will be, so let's say random events. You can also say that they happen singly, meaning that you don't have all the items all at once. So those are the assumptions for Poisson distribution from the previous chapter. So let's write down the distribution first. So for letters, it will be 3. And then for parcels, it will be 1 per weekday. So the first question, so let's rewrite this. So basically, let's write, for example, Q would be 3 plus 1, which is 4. So you know how to calculate the lambda for Q. It's just 3 plus 1. So the first question asks the probability of the total number exceeds 5. Exceeds 5. So this would mean that you have 1 minus PQ smaller or equals to 5. Okay. So then what you need to do next is just to list down PQ equals to 0, PQ equals to 1, PQ equals to 2, PQ equals to 3, PQ equals to 4, and then PQ equals to 5. So you just need to minus out all that. So you have 1 minus e minus 4, 4 power 0, and then 0 factorial, e power minus 4, 4 power 1, here you have 1 factorial, e power minus 4, 4 power 2, then you have 2 factorial, e power minus 4, 4 power 3, then you have 3 factorial, e power minus 4, 4 power 4, 4 factorial. Then finally e power minus 4, 4 power 5, and then 5 factorial. Once you calculate all that, you will find that this is 2149. Part B. Probability that in a randomly chosen working week of 5 days, the business receives more than 20 but fewer than 24. So the first Poisson distribution is per weekday. So meaning it is 1 day. Now you need to find 5 days. Okay. So let's define another Poisson distribution called R. So Q is for 1 day. Previously we also mentioned that you can ratio up or down the Poisson distribution just by ratio. So if 1 day is 4, basically 5 days will be 4 times 5, which is 20. So the question asks you to find the probability that it receives more than 20 but less than 24. So this means that you need to find something like this. We are not doing the normal approximation, so you can just list down what are the numbers in between. There will be 21. Sorry, not Z, but R. 21, 22, and 23. So this will be e to the power of minus 20, 20 power 21, divided by 21 factorial, plus e to the power of minus 20, 20 power 22, then you divide by 22 factorial, e to the power of minus 20, 20 power 23, and then 23 factorial. So this will give us 0.2284. So that's all from this chapter, all the examples. So this is quite a short chapter. So tomorrow we will have another video on the chapter 4. Okay, thank you.